Two things. If you've got questions regarding the homework on how it was graded or what I was looking for, please take a look at the key I posted to our Canvas page. It's a module most of the way down, just above the class scan section, my typed up version of the key. If you're still like, well, why did I lose a point for this? Read that first, then come talk to me and we'll talk about rearranging or what was the miscommunication, what I was looking for versus what I read. Second, chapter 3 is due on Friday. Don't forget. Okay. Descriptive statistics. Primarily when we deal with quantitative data as opposed to qualitative data. So I'm dealing in numbers. It could be continuous, it could be discrete, that's less relevant, but usually we're looking at ratio data as opposed to interval data. And when we describe a sample, we get a statistic. When we describe a population, we get a parameter. So most of what we're doing is examining our statistic to then make comments about the parameter for the population. We're still going to try and describe the same three things we were talking about with the graphs and the visual idea. So I'm talking about center and variability and shape. So let's start with some assumptions. I'm going to assume that I have legitimate data. I did a good sample. I have an unbiased source. I'm trusting that the data that I have is relatively complete. We'll figure out how to test that in a little while. Here's an example. J.D. Power, the automotive statistical analysis group, analyzed 2022 models of 33 different vehicles and determined the number of defects per 100 vehicles. Now, a defect in this case could be anything from a paint chip to a major engine problem. So defect here is a very broad category. And I see a bunch of information that's up here, and I don't know what the hell it means. But I see here name and number of defects. Let's look at this column of data right here. Let's think about this for a minute. I've got a wide range of numbers here. So let's make a histogram. If I sort the information, my smallest number is around 140, and my largest is about 250. I mean, 256, 260, somewhere in that range. I use Sturge's rule, which says I should have a bin width of about 20 or 21. On the left picture, I did a bin width of 21. On the right picture, I did a bin width of 20. That's a little easier. It's a nice round number. Let's work with that one. So if my bins go 130 to 150, 150 to 170, this right-hand picture, what do I see? Oh, wait a minute. Do I see a modal class, a peak, anywhere in that graph? Kind of. In the one on the left, it looks like it's in the 180-ish range, 160 to 180, 180 to 200. Here it looks like it's in the 170-ish range, but there's this next peak a little further over. It isn't quite as high. I would say that that is a modal class. It's the single highest class. So my center should probably be down at that end. But if that's the case, do we have a skew, a shape? Well, if I see the center, the peak being more to one side, then I would expect that I would be skewed the other direction. My tail should go off in the other direction. If the middle is off to the left, then my longer tail is to the right, maybe. But this is just a histogram. I'm not sure I like this enough on its own to think of this as a measurement of the center of my data. Maybe a little bit about shape and variability, but there isn't enough here at the moment. There's no meat to this. So instead of just relying on a picture, let me ask, how can I find a mathematical definition of a center? Well, it turns out that there are lots of different mathematical ways to measure center. What measures of center do you already know? If I want to summarize my data, number of defects per 100 vehicles, house prices in Greensburg, salaries of people working at Seton Hill. What should we look for as a measurement of the center there? Emily?
Average.
Average. What's an average?
All the numbers added together divided by the amount of input you have. Number of views.
So I'm going to be another geek for a second. We don't call this the average. We call it the mean, the arithmetic mean. So if I have a set of data, x1, x2, all the way up to xn, the average is the sum of them divided by how many there are. Absolutely. That's for a sample, right? Because I had little n. If I had a population, just change that to capital N. Now, I'm going to be a geek again. One of the things that gets tedious is to write that pluses and the dot, dot, dots there. So in mathematics speak, we tend to abbreviate this. I use a capital Greek letter sigma to mean sum. And then I need to index that. So I'm going to use an I. We'll let I count through our numbers. I goes from 1 to little n, xi. That means take the first value of I, plug it in. Second value of I, so it's x1 and x2 and x3, and then this means add them all up. Oh, I got to divide by n, right? There. I could just as easily write that 1 over n in front. And this is actually the way I see this formula written in my textbook. Symbolically, when we talk about the mean, we write that symbol. For a sample. So that's the statistic, the mean. But when I talk about populations, I don't use regular Roman letters. What do I use instead? We tend to use Greek letters for our parameters. So if I want to do this for a population, then we'll write mu. That's an M, mean. And that will be 1 over capital N. I equals 1 to capital N, xi. And the only difference between the formulas is which n I use. And the only difference between the symbols is whether it's in normal letters or in Greek letters, Roman versus Greek. So when I'm describing my numerical data with an average, what am I getting? What does an average represent? We made a lot of different plots. The histogram was just one of them. If I make a dot plot of my information, we would have a number line, and all of those would be little dots floating around on the number line, right? I need you to picture, if you will, grades. If you are getting an exam grade in a class, you get a grade between 0 and 100. I'm going to ignore extra credit for the moment. Your exam grade goes somewhere between 0 and 100, right? I want you to take a little weight. A penny, a nickel, whatever, just the same thing for every student. Here's a meter stick. Every centimeter has a number on it. Put a penny on your number. Whatever grade you got. So now I have a stick with a bunch of weights on it. And I'm pretty sure that you all are going to do good. So they'll be over on this end where the high grades are, not down here on the low grades. So I have the stick with all these weights on it. Where do I balance it? Unfortunately, no. I don't actually balance it at the median. We haven't even described what a median is. I actually balance it at the mean. It turns out this number represents the balance point where I would put my finger so that all of the weights balance perfectly. So the average represents a balancing between where they are and how heavy they are. So the further out something is, the more weight it pushes down with. Well, the more torque, technically, the force one would use. The longer the arm, the more torque you have. Anybody who's ever tried to change a tire, they give you that lovely little wrench to turn the lug nuts on your car, and it's only about that big. That's infuriating. You take a pipe, make the thing this big, and you turn it really easily because you've increased your leverage. If I have a weight that's this close to where I want to turn, where I want to balance, that's not pushing very hard because it's a short measurement. The further away it is, the more it pushes. And so I have to balance all of those spread out dots in my dot plot. Now, there's just one problem.
Tell me what in parentheses, what that word is.
Fulcrum.
And
LCRUM. So in a teeter-totter, the fulcrum is that thing in the middle where everything is balanced. Literally, when I draw them, I tend to draw my fulcrum like that. And then each of my little numbers would be little spots out there, right? This one all the way off to the left, because it's so far out, torques harder than the ones that are on the right because they're closer together. Even though there's more on the right, the further out that is, the heavier. An experiment. When you go home, or wherever you go from here, take a non-uniform object, a baseball bat. Personally, you could probably use your tennis rackets really well. Put one finger at the head and one finger at the foot. Bring your fingers together, keeping it balanced. You'll end up not necessarily right in the middle, but closer to one end or the other. I do this with a baseball bat really well. You end up way towards the head because the head's heavier. There's more stuff there and less stuff down by the handle. So this pushes less than this. That's how you find what in physics is called the center of mass. It's exactly where the average of the weight is. When the baseball season began this year, they started talking about torpedo bats, and that the Yankees set a record because they used this new bat. Anybody follow baseball? I follow game much. Do you know why that bat was so controversial? It was a different shape. It changed where the center of mass was and made it easier to swing and make the center of mass connect with the ball, launching that sucker out of the park. They just found the average. The problem with using mean comes from its sensitivity. What do I mean by sensitivity? Here are 5 numbers. Find the average. Five. You would think that if I just change one number, it would change the average not all that much. It depends on which number I change. The further away a number is, the more its change matters. You would say, well, okay, the middle of this data, the middle is 5. That's what average tells me. I didn't change anything except the last number. What's the average now? Isn't it more than actually 7? No, I know you're right. I added 10 because it's now 30 instead of 35 instead of 25, right? Imagine right here in this room, there are 9 people. I would like to know the average salary of the people in this room. Just a question. How many of you are currently employed? 1, 2, 3. That means 5 of you have a salary of 0. How long have you been employed at the job you're at? 3 years. I've been at this one 24. I think our salaries are going to be a little whacked, aren't they? So I have all of these salaries of 5 zeros, 3 moderate numbers, and then I've got me, who's been here 24 years. One really odd number, an extreme value, an outlier, changes the mean a lot. I'm making numbers up. Please don't take this personally. 5 of you don't have a job, or at least don't have an employment, that we were talking about a salary. a year, 3 years, 4.5 years, 24 years, right? What's the average? Have a calculator. Do not try and do this in your head. So if I were to lay these dots out on a line, we'd have 5 dots at 0, a dot at 10, a dot at 30, a dot at 45, and a dot way out there at 240. And in order to balance that on my fingertip, I need to put my balance point here. Is that a good description of middle? Not really. But it is, in a very good sense, a description of balance. So this is one of the most commonly used measurements of center. I could legitimately say, using these numbers, on average, each of us earns 36. Those of you that are in 0 are pretty damn happy about that, right? Well, yeah, but it's not true, is it? If this was a company, and these are, let's say, thousands of dollars, the CEO's earning 240,000, and a bunch of you are getting a shack. But the average salary is $36,000. That's a true sentence. It's just not reflective of the reality of most people, is it? So, Jason, you gave me another word. You gave me median. What is a median? Oh, wait. Hey, stop. Hang on. I need to write that remark down. Mean is sensitive to changes in extreme values. Make changes way out on the numbers, screws everything up. So, Jason, what's median?
It's like a little number.
Which means the first thing I need to do to my list is sort it. I normally sort small to large, but it isn't required. The median should be the same regardless of whether we sort large to small or small to large. Now, in our list, which I happen to put sorted, how many numbers are in that list? So what's the middle? Say again? Why 3?
Because you have 1, 2, 4, 5.
But that list has, I'm sorry, you were looking at the top one. I'm sorry.
Yeah.
Okay, so yes, that would be correct because there were 5 numbers up there. It would be the third one. But in this list of 9, it would be the 5th one. Because I would say, oh, if I put my median here, then there's the same number of bits down here and the same number of bits up here. So instead of splitting my list by balance, I'm now splitting my list just by count. How many are in the low half and how many are in the high half? So really, I'm just breaking it into a low half and a high half. So far, so good. So I could just as easily say about our list of salaries, the middle salary earned in this room is 0. Now, if I'm trying to make this room look rich, should I give you the measure of center that's 36 or the measure of center that's 0? But if I'm trying to make this room look poor, I should give you the middle that says 0, shouldn't I? Neither is false, but they present very different appearances. What happens if the number of things in my list doesn't actually have a middle? Here's my new list.
In this case, you take the average of 7.
I go to the middle. It should be there. Let's average those. The only time this is going to happen is when you have an even number of things in your list. If you have an odd number of things in your list, you will hit one of the values. If you have an even number of things in your list, you'll be between two values. I tend to remember where it is by counting from the low end, halfway up the list. But if I have an odd number, half is going to be a fraction, right? Here I have 6 numbers. Is the median the third one? It's between the third and the fourth. I really should be above 3. But up here I had 9 items. What's half of 9? 4.5. But I didn't use 4.5. I used the 5th one. I need to go up a bit. Aha. I need to go up a bit. Hold still. If I have an odd number of things, then n plus 1 becomes even. When you divide by 2, you get a number. 9 plus 1 is 10. 10 over 2 is 5, the 5th thing. If this value is not a whole number, we average the 2 values we are between. So if I get 3.5, then I take the third and the fourth one and average them together. This is not what the median is. This is what spot it's in. So I had 9. 9 plus 1 is 10. 10 over 2 is 5. Go to the 5th number. I had 6. 6 plus 1 is 7. 7 over 2 is 3.5. I go to the 3.5 slot. So I take the 3 and the 4 and average those. Let me go back to our JD Power numbers for a second. Here's our histogram way over there in the second column, the B column. Those are our data values. I'd like to know the average. I'd like to know the median. I don't want to have to type this crap out, add up all these numbers, then count how many there are and divide by it. I don't have to. Excel already does. So I can go over to a blank cell and issue the command, tell me the average, equals AVE. Oh, look there, right there. I start typing, it says average. I want to use the average. I have to be able to spell it properly. average, parenthesis. Where's your numbers? All I have to do is go over and highlight my numbers. Enter. According to this, the average is 188.6. I can round off. If I want the median, equals MED. Look, MED, and it says you can use the median. Median of. Same list. Oop, too far. There. The median's 185. So half of my numbers should be below 185 and half of them should be above. If I'd sorted that list, we could actually physically draw out where they occur. I think I did that over here. Yes, no. Here's the sorted list right here. Now there are, turns out to be 22 numbers in here, right? Sorry, no, 33. 33 is odd. What position is the median in? 33 plus 1 divided by 2. 34 over 2. 17. Notice the one in yellow is number 17. And that median value is 185. And that means there are 60 with lower numbers, sorry, 16 with lower numbers and 16 with higher numbers. Because this list has smallest at the top, I keep gesturing up and saying smaller. I know that's weird. Normally I would gesture left, but I didn't write this list horizontally. It wouldn't fit on the screen if I did. And there I see, right there in the middle where it says, between the two column sets, I see mean, count, and median. I see a bunch of other crap too. We're not worried about that yet. Questions? Please notice in this list, my highest number is 71. That's extremely far away, right? Compared to all the other numbers. So I have a really substantially way out there number. If I change that from 71 to 17, does the median change? No. So here's the difference. Mean is very sensitive to changes in the extreme values. Median is not. Grades. I think this is an example I stole from the textbook. Students have taken 5 quizzes. Tom has quiz scores of 20, 40, 70, 75, and 80. Jake, 60, 65, 70, 75, 80. And Mary, 50, 65, 70, 75, 90. What is the median quiz score for my students?
7.
For all 3 of them, right? The middle number in all 3 lists is 70. Find the average for each list. My symbol for average is X bar. I put a subscript T, J, M for each student. So this is Tom's average, Jake's average, and Mary's average, respectively.
One had enough, 57, eight, very good, next, good, 70.
So it's quite possible to have widely differing individual scores and still have same average. It's possible to have really widely differing averages and still have the same median. Okay, a question for you. What real life things that you have already encountered use mean as a center?
Grading scales.
Grades, right? Every time you get back an assignment, if you go on Canvas and you look at your grade, there's a way that it'll show you what the average on that assignment was. It won't show you the median because the median doesn't help us in any deep way. The average, though, for grades seems to be a more useful measurement so far. Those of you on athletic teams, you hear averages everywhere. You rarely hear about somebody's median batting performance. So what does use median more often than mean? I mean, I can't just mention it and say, this is useless, you'll never see it. I spend at least 10 minutes on this. We should use it for something. I want to use median when those extremes are problems. So if I'm talking about salary, average doesn't seem to do a very good job if I've got one rich monk at the top and a bunch of peons, right? If I'm buying a house in Greensburg, and I asked you to look up right now home prices in Greensburg, you would get the median home price. Why?
They don't want to add in those really expensive mansions that are just like a few of them turned out.
If I walk down to Mount Thor Road on the other side of Caritas and make a left instead of a right, if I make a right, I'll end up on, I just forgotten the road number, 130. But if I make a left, I'll end up on Mount Thor Road. The first house on the corner of Mount Thor Road, right past Caritas, is gorgeous. It's like 22 rooms. It's huge. It's $3, $4, $5 million. I don't think that's going to be relevant. And it's certainly going to move the average up quite a bit when compared with the houses that are at the bottom of the hill across the street that are single family, 2-bedroom, 3-bedroom houses or smaller. Some of them with very small yards, some of them with moderately. So we more often get median home prices. Car sales, the same way. Things where the extremes are going to be a problem. You'll find median income described in populations about cities. What's the median income in Westmoreland County? Not the average. What's the median income? 50% of people are making less than that number, 50% are making more than that number. That's more important as a measurement for the population to accurately reflect upon as opposed to the 1 billionaire in Westmoreland County who's throwing us all under the table, right? So I need to look at when I use each of these pieces. And it always comes down to whether or not I think there are extremes in the data. Questions? There's one other commonly used measure of center. We spoke about a modal class. So let's talk about a mode. A modal class is the class that gets used the most in our histogram. So a mode is the value that gets used the most. Now, in numerical data, we're really just looking at individual numbers. So when I was talking about the dot plot, this would be whichever one had the biggest column of dots. In a histogram, they might not all be the same number, they just might all fit in the same class. But in a dot plot, in order to stack like that, they have to be the exact same number. In all of these quiz score lists, is any number repeated? Per person. Nothing's repeated per person. So none of these lists have a mode. If all of the numbers are unique, there's no mode. If, on the other hand, we have two or more numbers that all tie for first place, if we had two of them, we'd call it bimodal data. If we have more than two, we'll call it multimodal data. I tend to find that most people will go at most to two. And if you have like 3 or 4 or 5 of them, they'll give it up. No mode. So most of the time, we would go with bimodal, or again, say there's no mode. So again, I can go back to my JD Power data and ask this very question. In the JD Power data, is there repetition? Now, sometimes having the same numbers show up more than once is easy to explain. If I looked at all of the individual football scores over the weekend, each team, not the games, each team, I would expect to see multiples of 7 a lot, wouldn't you? Or things that are maybe ending with multiples of 7 plus some multiple of 3. That would make sense. How many football teams do you know have ever, in their entire history, had a score of 1? You can't score just 1 point in a football game. The minimum score you can get is 2 for a safety. After that, it's 3 for a field goal. You can't do that. You can a score of 4, maybe. You could have a really bad defense and get 2 safeties. So, but you can't get a score of 1. It doesn't work. But I can get a lot of games that end with a team having 14 or 21 or 28. Those make sense. So sometimes mode is explainable by the situation. And sometimes it's not always helpful. This is actually fairly helpful in categorical data. Likert scales, right? I like it. I like it a lot. I just like it. I hate it. I hated a lot. Well, then that would be a good category distribution. And I'd want to know which is the category we hit most often. We were talking about that when we talked about categorical data, nominal data. We said the best thing we could do was comparative work, frequency counts. The mode gives me that. Excuse me. On our JD powered data, I can do something called a descriptive statistics block. There's a lot of stuff here. That descriptive statistics block is a giant pile. Where the hell did it come from? I'm going to highlight my defect data. And I'm going to go back to that data analysis setup. I need to move you there. So under data, I go over here to data analysis. This is where we found the histogram idea, right? If I scroll up, there is a block says descriptive statistics. If I ask it to do the descriptive statistics, it'll ask me for an input range. I tell it where the data is. Hey, the data is in columns. And then it will spit out this block. Oop, forgot to push the button down here. Summary statistics. That's what I want. I want the summary of all of this information. And this is the same block that I was just looking at. Please notice 3 of the top 4 of the centers we were just talking about. Mean, median, mode. If I think there's more than one mode, the command in Excel is mode, M-U-L-T, multiple, as opposed to S-N-G-L, mode singular. Questions? It turns out that between the 2 centers, mean and median, we can determine at least basic skew. If more of my data is around the mean and it spreads out, then my skew will be in that direction, right? But the median will be where most of the data is, right? It's the 50% line. It doesn't care if there's one way out there. The mean cares. The mean moves closer to those extremes. So if I had data that had a bunch of really low values in it that were way out there and most of them were up here, then I would expect my mean to be slowed down a little. But my median wouldn't move. So I would expect my mean to be lower than my median. On the other hand, if it was skewed to the right, I would expect my mean to be higher than my median because it gets pulled in the direction of those extremes. Page 102. 102. Picture. If my data is symmetric, then my mean and my mode and my median will be the same. If my data is skewed left, my mean will be lower than my median. Ideally, that'll be lower than my mode. Skewed right, the exact reverse. It is rare for us to consider mode in looking at skew. More often, we just compare mean and median. And the mean goes in the direction of the skew compared to the median. So if the mean is below the median, we're skewed low to the left. If the mean is above the median, we're skewed high to the right. When the difference between the 2 is small, this isn't very helpful. When the difference is substantial, we'll see a lot of skew. There is another example on our Canvas page. That's this one that I was pulling it from. That's labeled the JD Power one. But then there's also this example, which is about civil service exam scores. I think the mean would be useful. Here's my sorted list. Here's my mean, median. There are 2 modes in this group. So here's a way to do these calculations directly. Please take a look, and we'll continue this on Friday. I will see you all then. Have a wonderful rest of your day. Hey, there's even a histogram down here. You can check what that skew looks like.